Hello and welcome back to our maths lesson. I am Mrs. Ray, your grade 9 maths teacher. In our previous lesson, we looked at direct proportion and indirect or inverse proportion. In today's lesson, we are going to look at estimation and significant figures. And significant figures. Now, what is estimation? Estimation of numbers is rounding of numbers to the nearest or closest whole value. And when we estimate numbers, we use the wavy equal symbol for approximately equal to. Approximately equal to, okay? This is the symbol that we use for approximately equal to. Okay, we look at some examples on how to estimate numbers. We have done that in grade 8 and grade 7. So this is going to be a recap of what we have already done in grade 7 and 8. Okay, let's look at the first one. I have 61.35. I want to round this to the nearest whole number. Okay, what is it going to be? When we estimate, we know when we are rounding of numbers, we always look for the next digit before the one that you are going to round off. Now, 61.3, okay, we use this, if it's greater than 5, we add 1, or not greater than, but equal to or greater than 5. If it's strictly less than 5, we leave the answer as it is. So we'll just look at this so that it reminds us what to do. Now, if you look at 3, which is the digit after the decimal point, because we want to change 63 to the closest whole number. 3 is less than 5, so we are going to leave 1 as it is. So 61.36 is approximately equal to 61. Now, let's look at another example. 64 rounded off to the nearest 10. Now, if we look at 64, we look at the unit, okay? If the unit is less than 5, then we leave 6 as it is. So 64 to the nearest 10 is equal to 60. Now, let's look at 1, which is in the hundreds, okay? We want to round 753 to the nearest 100, okay? Now, if it is in the hundreds, we look at the tens. If the tens is greater than 5, then we add 1 to the 100 value. So, in this case, 753, when rounded to the nearest 100, will be approximately equal to 800. Okay. Now, we can also round off decimal numbers to the correct number of decimal places required. Let's look at an example where we are going to round off decimal numbers to the correct number of decimal places. We have 18.563, correct to 2 decimal places. Again, for this one, we are going to look at the digits after the decimal point. Now, if we look at 18.563, we want to round this off to 2 decimal places. Now, we will concentrate on the 2 digits 5, 6. The number after 5 is 3. Since 3 is less than 5, we are going to leave 6 as it is. So, 18.563 to 2 decimal places will be approximately equal to 18.56. Okay. Let's look at one more example. Let's see if I have 1.035. I want to change this to correct to 2 decimal places. Now, I am going to look at the 2 numbers after the decimal point, which are 0 and 3. Now, when I look at these numbers, 0 and 3, we can see that 5 is greater than, is the number that we need to increase the number that we want to change it to the decimal place required. So, 5 is the number after 3, so we are going to add 1 to 3. So, 1.03 to 2 decimal places will be approximately 1.04. 1.04, we add 1 to 3 because 5 is the one that is after the 3. Now, that brings us to the end of our lesson on rounding of numbers to the nearest whole, closest whole values, and to the number of decimal places that are required. We are going to now look at how we can apply these numbers again in significant figures. Okay, let's see what significant figures is. We have significant figures. Okay, significant figures really tells us the digits from 0 to 9 that are used in measurement. So when we are measuring quantities, we use these digits for measurement. Therefore, we are going to look at these numbers and we'll find out which numbers are significant figures. Okay. There are rules which we use when we are dealing with significant figures. Okay, rule number 1. All non-zero digits are significant figures. Example, 123 has 3 significant figures. 2. Zeros between non-zero digits are also significant figures. So if I have 205, 205 has 3 significant figures since this 0 here is between the 2 non-zero digits. Therefore, it is significant. Now, rule number 3. Leading zeros in a decimal number are not significant. Example, 0.0567 has 3 significant figures. These zeros here are called placeholders because they do not represent any value, so these are leading zeros, therefore they are not significant. Now, rule number 4, trailing zeros in a decimal number are significant figures. If I have 92.00, this has 4 significant figures since these two zeros are trailing zeros in a decimal number. They are significant. And the last rule, trailing zeros in a whole number are not significant. So in 540, we have two significant figures. So this zero here is not a significant figure. So 540 has two significant figures. Now, we are going to look at why these rules are very, very important when we round off numbers to the correct number of significant figures. Okay, let's start with the first example. Okay, our first example is 4,350. We want to round off 4,350 correct to two significant figures. Now, when we are rounding off numbers to the correct number of significant figures, we start from the first significant figure. In this case, the first significant figure is 4, and we count to the right. Now, we are required to write these two significant figures, so the second number is 3. Now, if we look at the next number after the last significant figure, 3, 5. Okay, as we can see from this, we say if the number after the last significant figure is 5 or more, we add 1 to the last significant figure required. So in this case, we are going to add 1 to 3, and our number will be 4,400, correct to two significant figures. These two zeros are actually placeholders, which indicate to us that this number is not 44, but 4,400, correct to two significant figures. Now, let's look at the next number. Okay, our next number is 1.2054, correct to four significant figures. We want to write 1.2054 correct to four significant figures. Now, we are going to start from the first significant figure, and we are going to count four significant figures to the right. Now, we have 1, 2, 3, 4. Okay, so these are the four significant figures. Now, for the next significant figure after the last significant figure is 4, which is less than 5. So, we are going to leave 5 as it is. So, our answer now correct to four significant figures will be 1.205, correct to four significant figures. Now, let's look at the last example. Our last example is 1.98, correct to two significant figures. Now, as we have mentioned earlier, we start always from the first significant figure and count to the right to the number of significant figures required. So we have 1.9. Okay, so 1 and 9 are the two significant figures. 8 is the next number after the last significant figure. 8 is greater than 5, so we are going to add 1 to 9. Now, when we add 1 to 9, that 9 will become 10, so we put down 0, put a decimal point there, and add 1 to 1. 1 plus 1 gives us 2. So, 1.98 correct to two significant figures is 2.0. Now, remember our rule number 4. A Trailing 0 after a decimal point is a significant figure, so this 0 is a significant figure, therefore 1.98 correct to two significant figures is 2.0. Okay, now that brings us to the end of our lesson. In our next segment, we are going to look at scientific notation.